Hey guys, welcome to your notes for today. I just kind of quickly wanted to go over a couple examples in case you need to see these. So I'm going to go ahead and skip this intro problem because you should know that the blue and red lines represent distances on the graph and that forms a right triangle. So then we can use the Pythagorean theorem. So you can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So if I graph the ordered pair at 3, 0, and then 7, -5, you see that I get this triangle, this right triangle right here. So it started with a point at 3, 0. Then they graphed a point at 7, -5. And they... Is there a line tool? Okay, I apologize for my bad lines. But, oops. But what we get here is a right triangle. So when we have a right triangle here, we can find the distance between this point and this point. We can find the vertical distance, and then we can find the horizontal distance. When we find the vertical distance, we find the distance to be 1, 2, 3, 4, 5. So our distance between 0 and -5 is 5, so that side A or B is 5. And then our side from 3 to 7, well, we go over 1, 2, 3, 4 units there. So then we need to find the hypotenuse. And when we have that, we just use a squared plus b squared equals c squared to find out what x is, or find out what our hypotenuse is. So let's go ahead and plug in for 5 for our a here and 4 for our b. So we get 5 squared plus 4 squared is equal to c squared. So you get 25 plus 16 is equal to c squared. When we add 25 and 16, you get 41 is equal to a c squared. We have to get c all by itself, so we take the square root of both sides, canceling out that square. And the square root of 41 comes out to approximately 6.4, meaning that the distance between points 3.0 and 7, -5 is about 6.4 units. And that's how you can solve the distance between 2 points using the Pythagorean theorem. And we can use this method for finding the distance between 2 points when we have a certain problem that looks something like this. When they give you when they give you a grid and they give you a point to try to find, it sometimes is better to use the Pythagorean theorem because it's nice and easy. You already have a grid there, might as well use it. So it is important that you know how to do this as well as use the distance formula. So go ahead and pause the video, try to solve this problem, and then we'll go ahead and go over it. Okay guys, so you should have plotted a point at 1, 3. That's our first point right there. And our other point is at -2, 4. So again, we have this little diagonal distance between the two, but we also have this horizontal distance and this vertical distance. So this vertical distance is obviously 1. This horizontal distance is 1, 2, 3. So we have a right triangle formed here with a 1, a 3, and we don't know what the hypotenuse is. So we plug that into our Pythagorean theorem, which is a squared plus b squared equals c squared. And we get 1 squared plus a 3 squared is equal to c squared. So you get 1 plus 9 is equal to c squared. 10 is equal to c squared. Have to take the square root of both sides. And when you take the square root of 10, let's go ahead and round to the nearest tenth. So if I take the square root of 10, I get 3.16227, yada, 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 yada. And let's go ahead and just round that to a 3.2. So approximately 3.2 units for C. Now there's another way we can solve these, and we talked about this briefly yesterday, but let's go ahead and talk about it again. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So how you solve this formula is first you subtract x2 and x1, then you square it. Then you subtract y2 and y1, square it, add those together, and then take the square root. Those steps might seem familiar, and that's because, well, these are the exact same things we're doing when we use the Pythagorean theorem. You actually get the distance formula from the Pythagorean theorem. And we can see that here, because the distance of A is just the distance between those 2 points squared. Because A is just the distance between those 2 points, and B is just the distance between these 2 points. And if we take the square root of both sides just to get C, well, there's our distance formula right there. So let's take a look at what this kind of looks like. So on this problem, it says on the map, each unit represents 45 miles. That's important, and we'll have to talk about that in a minute. So when we're talking about maps, it's important to remember what each unit represents so that we can multiply however many units we have at the end times our conversion rate. But we'll talk about that at the end. First, it says West Point, New York is located at 1.52. Annapolis, Maryland is located at negative 1.5, negative 1.5. What is the approximate distance between West Point and Annapolis? So there's actually 2 different ways we can do this. We can use the Pythagorean theorem with this triangle that's formed right here, and we can use the distance formula as well. So let's go ahead and solve using those 2 methods. So go ahead and pause the video, use the method that you like, and I'll talk about both the methods here in a second. Okay, so for the Pythagorean theorem, we need to let C represent the distance between West Point and Washington and Annapolis, right? West Point and Annapolis, well, that will give us our hypotenuse here. Our A would be from the distance between negative 1.5 to 1.5, which negative 1.5 to 1.5 is a distance of 3. And B is a distance of negative 1.5 to 2, which is 3.5. So this distance is 3.5, this distance is 3. So now we have all the information we need for solving the Pythagorean theorem. So we have a squared plus b squared equals c squared. So I have a 3 squared plus 3.5 squared is equal to a c squared. If you don't know what 3.5 squared is, go ahead and plug it into your calculator like I'm doing now. And you get 9 plus 12.25 is equal to c squared, which is 21.25 is equal to c squared. So now we need to take the square root of both sides. And when I take the square root of this, I get, sorry, not the square root of that. I need to take the square root of 21.25. And now we get 4.6. Now notice 4.6 is the units, not the total miles, because remember on that last slide it said that each unit represents 45 miles. But let's go ahead and use the distance formula and see if this is different or the same. So you get x2 minus x1 squared plus y2 minus y1 squared, and the square root of all of that. So when I take x2 minus x1, so I have negative 1.5 minus 1.5, well, I get negative 3. And I have to square that to get 9. I need to add that. I have a negative 1.5 minus a 2. Well, that gives me a negative 3.5 squared, which gives me a 12.25. That looks familiar. When I add those two, I get 21.25. I need to take the square root of this because all of this is underneath the square root. And U is equal to C. So you get C is equal to 4.6 again. Now notice we have 4.6 units, but what does each unit stand for? Each unit stands for 45 miles. So we really need to multiply this 4.6 times 45 to find out the distance in miles between West Point and Annapolis. And when you multiply 4.6 by 45, you get 207. So 207 miles is our final answer, no matter which method you use. Hopefully that makes sense. If that does, you can go ahead and start working on your homework, but I'm going to go through, I think, 1 or 2 more examples just to make sure we have it down. Let's go ahead with these 2 examples. So, again, you can use the Pythagorean theorem or the distance formula. I'm going to go ahead and use the Pythagorean theorem for this first one and the distance formula for this one, because I have decimals there and that might get a little tricky. Not really, because you're moving negative 2.3 to 6.3, so that's pretty easy to tell the distance between. But this one's easy to use the Pythagorean theorem for. So we have negative 5 and positive 1. So we have a point right there. And we have 2, 4. So we need to find that distance between them. So we need to find the horizontal and the vertical distance. Well, between the vertical distance of 4 and 1, well, I'm going 1, 2, 3. So that distance is 3. And to negative 5 to 2, I'm going, well, 5 here and then 1, 2. So 7. So we end up with this right triangle with 3, 7, and x. So that gives us 3 squared plus 7 squared is equal to x squared. 9 plus 49 is equal to x squared. 58 is equal to x squared. Take the square root of 58. So let's go ahead and plug in 58. Take the square root of it. And you get 7.6 approximately for your distance. Let's go ahead and use the distance formula just so you have another example of that. So I have x2 minus x1 squared plus y2 minus y1 squared. Let's go ahead and make this first point at x1. So this first point, 4, negative 2.3, will be x1 and y1. And that second point, negative 1 and negative 6.3, we'll go ahead and make that x2 and y2. So for our first point, we have x2 minus x1. So we have a negative 1 minus a 4. So we have negative 5 squared, because remember we're inside the parentheses here, it's squared. So I have 25 plus, well, y2 is a negative 6.3 minus a 2.3. which gives you a negative 8.3. You have to square it. Oh, sorry, we're subtracting that negative. So we really get not negative 8.3. We're really adding a positive there, because we were subtracting a negative, so we're really adding a positive. So then you get negative 4 squared to give you 16. So we get 41 square root of 41. I think we already found that today, but let's go ahead and plug that in. Square root of 41 is about 6.4 units for this distance. Hopefully that makes sense. If it still doesn't make sense, please send me an email. I hope you have a wonderful day. You can go ahead and work on your homework. I'll see you all later. Also, if you email me the word bubbles, I'll give you 5 points extra credit. See y'all later.